A relation is a rule that relates values from a set to a second set of values.
Fat Math, the right path to develop the fat brain that you've got. Hello, everyone, and welcome to Fat Math TV.
In this lesson, we will define functions and relations and identify whether the given is a function or merely a relation. A relation is a rule that relates values from a set to a second set of values. So as what you can see here, we have two sets. We identify an element of a first set, and then we connect it, or we have a correlation with the elements of the second set. So this first set is what we call the domain of the relation, and the second set is, we will call that the range of the relation. While a function is a particular type of relation wherein each element of the first set, the domain, is related to only one value in the second set or the range by some rule. So from the definition, we can say here that functions are relations. So all functions are relations because a function is a relation. But of course, there are other relations that are not functions. Or a relation can be also interpreted as the set of ordered pairs, while a function is a set of ordered pairs such that no two ordered pairs have the same first value but different second values. Meaning to say, if your first, what they call this, first component here is 1 and it's paired to 2, then you cannot pair 1 with other values anymore. A function can also be interpreted as a machine. Like for example, in this case, we put something here inside. Let's say we put an integer. So our domain is going to be the set of integers. And then we will do something. The operation is, if it is even, then we put out 0, and if it is odd, then 1. The output is 1. For example, if your integer is 1, since 1 is odd, then you have to return 1 or to put 1 as the output. And if you're, for example, you put an integer which is 10, 10 is even, therefore, the output should be 0. So all outputs are only 0 and 1. So each integer will have an output either 0 or 1, and it cannot be both 0 and 1 because an integer can be identified as either even or odd. Another example, let's say for example you have a plane figure. Okay, you input a plane figure and then your output is going to be its area. So any plane figure will only have one area. So this is a function because no plane figure will have two areas. So the area will only be one. So if for your input, you will have only one output, then it's going to be a function. Unlike here in the examples at the bottom, you have here, we will input a real number. And for every real number that we put in this machine, the output will be its square root. For example, if you will put 9 here, 9 is a real number, and you take its square root. But the square root of 9 is either 3 or negative 3. So there can be two answers. So if there will be more than one answer, or if there will be two answers, then your relation is not a function. Same here in the last example. If you have the name of the learner as the input and your output will be the cell phone model he or she has, then you may have two or more different outputs, because some learners have two or more cell phones. So they can answer, oh, I have iPhone 14. I also have Samsung Galaxy. So a learner may have what they call this two outputs. So that pairing or that relationship will not constitute a function, because for a function there should be only one output. Okay, which of the following is a function? Here, we will input the name of the learner and output is the subject teacher. For the second one, the name of the learner and the output is his or her student number. So for this example, this one, the first one, the name of the learner and the output is subject teacher is not a function, because one learner may have different subject teachers. So each learner, for one learner, let's say Ben has different subject teachers. So the output will be many. So you are pairing Ben to different subject teachers. So this is not a function. Unlike in the second one, this is a function because the name of the learner, for example, Ben has only one student number in his school. So this relationship constitute a function. A function can also be a set of ordered pairs. So for a relation, this is an example, 1, 2, 1, 6, 5, 9. For a function, we have here 1, 3, 2, 4, 3, 7. So from our definition a while ago, for a function, for a relation, it can be any pairing, any pairing. But for a function, it has to be that your x value or the first value in the ordered pair should only have one pair, like this. 1. The pair of 1 is only 3. The pair of 2 is only 4. And the pair of 3 is only 7. No other pair for 3, for 2, and for 1. Unlike in this example here, this is a relation which is not a function because the pair of 1 is 2. And the pair of 1 is also 6. So you are pairing 1 to both 2 and 6, which is not allowed in the definition of a function, because each element in the domain should only have one pair from the range. So if you will take a look at this, the domain of this relation is the set containing 1 and 5, and the domain is the set containing 2, 6, and 9. While for this function here on the right, the domain is the set containing 1, 2, and 3. That's the x values. And the range is the set containing 3, 4, and 7. This one, 3, 4, and 7. Which of the following relations are functions? Also identify the domain and the range. So you have to check if each x value is paired only to one y value. If one x value is paired to 2 or more y values, then the given relation is not a function. And then for the domain, just identify the x values, the first or the x coordinates of the ordered pair. And for the range, you just identify the y coordinates of the ordered pair and put them together in one set. Okay, let us answer. Number 1. This is a function because the pair of 1 is only -1. The pair of 2 is only 4. The pair of 3 is only 0. And the pair of 5 is only 6. They don't have other pairs. How about number 2? We have to check, or we have to identify the domain and the range first. So for the domain of number 1, we have the set containing 1, 2, 3, and 5. And for the range, the set containing -1, 4, 0, and 6. And the conventional way of writing a set of numbers is you write them from the least to the greatest. But anyway, if you wrote there -1, 4, 0, 1, it's still correct because these two are equivalent sets. I mean equal sets. Number 2, a set containing the ordered pairs 0, 2, 3, 1, 4, 2, and 3, 5. So as what you can see here, 3 is being paired to 1. At the same time, 3 is being paired to 5. So you have to check the x values if they're paired to only one y value. If they're not paired to only one, then it's not a function. So in this case, 3 has pairs 1 and 5, so it is not a function. And then the domain of the relation is the set containing the x values 0, 3, and 4. Here you have a 3, another 3, so you're just repeating 3. And then for the range, we have 1, 2, and 5. Here, 2, 1, 2, and 5. So we write only once the 2. How about number 3? The set containing ordered pairs negative 1, negative 1, negative 2, 1, negative 3, 1, and 0, 1. So you have to check if each x value is paired to only one y value. So negative 1 is paired to negative 1, so only one pair of negative 1. Negative 2 is paired only to 1. Negative 3 is also paired to 1. And 0 is also paired to 1. So this is a function. So take note that we are only checking if the pair of x is exactly 1. We're not checking if the pair of y is only 1. Like here, the pair of 1 is negative 2. The pair of 1 is negative 3. The pair of 1 is 0. But we are not checking on that. We are only checking of the x values. Check the x if it has only one pair in the y. Or check each element of the domain if it is paired to only one element in the range. So the domain is the set containing negative 3, negative 2, negative 1, 0. This is the set of all the x values. And for the range, the set of all the y values, we have negative 1 and positive 1. Number 4, set containing ordered pairs 0, 0, 1, 1, 2, 2, and 3, 3. So 0 has only one pair, 1 has only one pair, 2 has only one pair, 3 has one pair. So this is a function with domain 0, 1, 2, 3 and range 0, 1, 2, 3, the same set. And number 5, set containing 0, 9, negative 1, 1, 0, negative 9, and negative 1, negative 1. As what you can see, 0 is being paired to 9. At the same time, it's being paired to negative 9. And negative 1 is paired to 1. At the same time, it is paired to negative 1. So this is not a function. And it's the domain of this relation is the set containing negative 1, 0, and 1, 9, 1, negative 9, negative 1. So that's it. So negative 9, negative 1, 1, 9. So if you will write this again, this can be negative 1, 0. But anyway, they're the same. 0, negative 1, and negative 1, 0 are the same set. Okay, so that's it for identifying functions given the set of ordered pairs. So you just check the x values if they are being paired to only one y value. Functions can also be in the form of a table of values. So these are examples of functions. So this can be also interpreted as a set of ordered pairs, 2, 0, 3, 0, 4, 0. So the domain of this one is the set containing 2, 3, 4, and the range is the set containing 0. So if you want to check if this is a function, just check if each x is paired to only one y value. Does 2 have another pair? No, it's only 0. Does 3 have another pair? No, it's only 0. Does 4 have another pair? No, it's only 0. Meaning to say this table of values here is a function. Same with the second and the third. Each element in the first set in the domain is paired to only one y value. Unlike here in the second examples, in the second part here, these are relations that are not functions because as what you can see, x equals 0 is being paired to 3. At the same time, it's also being paired to 4. So this is not a function. Here, 1 is paired to 5. It's also paired to 6. It's also paired to 7. So this is also not a function. And here, we have negative 3 is paired to 0 and negative 3 is paired to 9. So negative 3 has 2 pairs, so this is not a function also. So to check if this table of values constitute a function, you have to check for the x values if they only have one pair. Okay, let's check if you already know how to identify which of the following are functions. Number 1, here we have a table with xy. 1 is paired to negative 2, 5 to 2, 9 to 6. For here, we have 5 to 1, 5 to 2, 1 to 3. And here, for the xy combinations, we have 1 is paired to 2, 2 is paired to 5, 3 is paired to 10. And for the last one, 0 is paired to 7, 1 is paired to 7, negative 1 is paired to 7. Which are functions? Try to answer. So the first one is a function since each x is paired to only one y. The second one here is not a function because the 5 here in x is paired to 1 at the same time is also paired to 2. And the third one here is a function because 1 has only one pair, 2 has only one pair, and 3 has only one pair. And the last one is still a function because you have to check the 0, 1, negative 1 if they are paired to only one value. Yes, the 0 is only paired to 7, 1 is paired to 7, and negative 1 is also paired to 7. So we have here 3 functions and 1 relation which is not a function. Functions and relations can be also in the form of an arrow diagram. We have here this set A is the domain of the function. The arrow is the pairing. That's the function. And the B here is the second set or the range. So this is the domain and the range. Here you can see that 2 is being paired to 5, 4 is being paired to 3, and 9 is paired to negative 1. And this is a function since each element in the first set in the domain is paired to exactly one element in the range. This one is also a function because 2, 4, and 9 are paired to only one value. 2 is paired to 5, 4 is paired to 5, and 9 is paired to 5. Each element of the domain is paired to exactly one element in the range. So this is a function. And number, or the third one here, we have 2 elements in the domain, 6 and negative 2. So each element is paired to only one y value. 6 is paired to 8. Negative 2 is paired to 8. So each of the element of the domain is paired to only one element in the range. As for the negative 3, we don't need to check that because that is not anymore in the definition of a function. For an ordered pair table or arrow diagram to be a function, you need to check the elements of the domain only. So you have to look only on the first set if they have only one pair. So you don't check anymore the other elements of the second set. Okay, we have here examples of non-functions. The first one here is we have 4 being paired to both 3 and 5. As what you can see, 4 in the first set or in the domain is paired to 3 at the same time it is paired to 5. Therefore, this relation is not a function. Same with the second one here. 0 is paired to 3, 0 is paired to 5, 0 is paired to 2, and 0 is also paired to negative 1. So you are pairing 0 to 4 different values, which violates the definition or the condition of a relation to be a function. So this is also not a function. And lastly, for this example, we have negative 1 is paired to 3, 0 is paired to 5, but 2 doesn't have a pair. So a functions, for a relation to be a function, it says that each element in the first set or in the domain should have one element in the y or exactly one element from the range. But this element 2 of the domain doesn't have a pair. So this is not a function. Okay, try to check if you already know or you understand how to identify, or you already know how to identify if the given arrow diagram is a function or not. The first one, 1 is being paired to 6, 2 is paired to 5, 3 is paired to 7. Is this a function? Yes, because each element in the domain is paired to exactly one element from the second set. How about this one? Negative 2 is paired to 8, 0 is paired to 8, 2 is paired to 8, and 4 is paired to 8. Is this a function? Check if each element of the domain is paired to only one element in the range. Is it? Yes. So this is a function. And then the third one, is each element paired to only one value here? No. 0 is paired to 3 at the same time it is paired to 5. So this is not a function. And lastly, number 4, this is also not a function because 3 has no pair. Each element from the domain should have exactly one pair from the second element. So since 3 has no pair, this one is not a function. Function as a graph. Functions can also be represented or illustrated using graphs. So the given here at the top are functions, while at the bottom are non-functions. So how will you identify if the given graph is of a function or not? You need to perform the vertical line test. A graph is a function if and only if each vertical line intersects the graph at most once. Meaning to say, if you will draw a vertical line anywhere on the Cartesian plane, you should only intersect the graph in at most one point. So either you intersect it at one point or you don't intersect it. If you intersect it at 2 points or more, then the function or the graph is not a function. So for example, here in our given, so if we will draw vertical lines, then we will only intersect the graph at most once. So here, we intersect once this vertical line. If we will draw vertical line here, once only, here and here. So we will only intersect the graph once. For the second one, also once, you will intersect the graph at most one point. So you will only intersect the graph here once. If you draw vertical line here, once only, here once, here you intersect the graph once. So the graph is a function. And for the third one, you only intersect the graph also once, and for the last one, also once. And then for the examples here at the bottom, we have here, because the vertical line test says that each vertical line will intersect at most one point. So we're okay with this vertical line. We're okay with this vertical line. For this one, doesn't intersect the graph. This one intersects the graph once, so that's okay. But here, we intersect the graph twice. So even though you can make only one vertical line that touches the graph in 2 points or more, then you can already conclude that that is not a function. Same here. This vertical line intersects the graph in 2 points. So that is not a function. Let us move to the second graph. If you will draw a vertical line there, the first one that we drew, it's no longer a function because it will intersect the graph here at 2 points. Okay. So that's a counter example. We were able to identify a vertical line that intersects the graph in 2 points. So that can already that is already sufficient to conclude that the function is, the graph is not a function. Same here in the third graph. Here we intersect the graph in 2 points. Here 2, here 2, here 1, 2, 3, 4 points. And the last one, we intersect the graph here at exactly 2 points here if our vertical line is this one. So if you can draw a vertical line that will touch the graph in 2 points or more, then the function is, or then the graph is not a function. Okay, so try this yourself. Number one, we have here a vertical line. That's the graph of the relation. Is it a function or not? For number two, this one, 3, 4, 5. So number one, that is not a function, because if you will draw a vertical line here, exactly the line, then you will intersect the graph in infinitely many points. Number two, that is a function, because everywhere if you will draw a vertical line, then you can intersect at only one point. Number three, this is not a function because we can intersect this at 2 points. The vertical line can intersect this in 2 points like this. So 2 points. And the fourth one, that is a function, because if you will draw a vertical line anywhere on the Cartesian plane, it will only intersect the graph once. Same with the last one. You will only intersect the graph once. Okay, take note, the lines have to be vertical. Okay, so we have first one is not a function. Second one is a function, not a function, function, and function. A function can also be in the form of an equation, like this. Y equals 4x plus 1, y equals x squared minus 4, and y equals x over x plus 2. Meaning to say, for each x that you will have, there is only one y value that corresponds to it. For example, when x is 1, this is 4 times 1 plus 1, that's 5. Y is 5. So for x equals 1, the y value is 5. If x is 2, 4 times 2 plus 1, that's 8 plus 1, that's 9. 2 is being paired to 9 only, and so on. So for each value of x, the pair from the domain is only 1. Same here. If x is, for example, 1, 1 minus 4, that's negative 3. So 1 is being paired to negative 3, and no other pair, only negative 3. How about 2? If x is 2, 2 squared minus 4, that's 0. So 2 is being paired to 0. No other pair for 2. Same here in the last example. For each value of x in the domain, there's only one pair from the range. How about this one? Y equals square root of x minus 3. Okay, so if we will interpret it as plus or minus the square root, then this is not a function. But if we will restrict it to be positive square root, then it can be a function. But in this case, we will interpret this as positive or negative square root of x minus 3. For example, x is 4. 4 minus 3 is 1. The square root of 1 can either be 1 or negative 1. So your 4 can be paired to 1 or negative 1. So you will have 4, 1 and 4, negative 1. So since your x value has two pairs from the range, then this is not a function. Same here, if you give values for x, that will give you two y values because of the existence of this squared in y. Okay, identify whether the given graph represents a function or not. No, not graph, but equation. Identify whether the given equation represents a function or not. Okay, number one, y equals x cubed minus 1, y squared equals x plus 1, y cubed equals x, x squared over 2 minus y squared over 5 equals 1, and y minus x squared minus 3 equals 1. So you have to check if for each x value, there's only one y value that you can get. If you can get two or more y values, then the function or the equation is not a function. So for number 1, that is a function because for every x, there's only one y. Number 2, since y has a square, then it is not a function because if you give values for x there, you will have square root and then you will have positive or negative. Y cubed equals x. For each value of x, you will get the cube root of that. Then that is still a function. And number 4, you have a y squared there, so that is not a function because you will have, again, 2 pairs for each x. And then, no, not 2 pairs for each x. You can have 2 pairs for x values, for some x values. And then the last one is a function. Whatever x that you will put there, you will get only a y value, one y value. So here again, the domain of a relation is the set of all possible values that x can take. So if we identify the domain of these functions, what is the domain of y equals 4x plus 1? So this is a linear function. You already learned linear function. And a linear function's domain is the set of all real numbers because you can have any real number for that, no restriction. Number 2 is a quadratic function, and the domain of the quadratic function is also the set of all real numbers, no restriction. For the third one, you have x over x plus 2, so you can have any real number except x equals negative 2 because that will make your fraction or rational number here as undefined. So you should not have negative 2 in the domain. So set of all real numbers except negative 2. And for this one, for the square root, the radicand should be greater than or equal to 0. So x minus 3 should be greater than or equal to 0. So your value for x should be greater than or equal to positive 3. So you can only have real numbers greater than or equal to negative 3. That's the domain. And then for the second to the last, you have set of all real numbers from negative 1 to 1 because that will be the values that will give you a real value for y. And for the last one, you will have the set of all real numbers less than or equal to negative 1 or greater than or equal to positive 1. You will learn later on that the graphs of these relations are circles and hyperbola, and you will also see their graphs to confirm that these domains really are their domains. So find the domain of the following relations. So here you have y equals 3x cubed minus 2. That's a polynomial function of degree 3. And then number 2, we have here rational function. We have 2 over x minus 1. So you should identify only the value of x. That will make the denominator 0, and that you don't include that in the domain. And then for this one, you should make sure that the x values are greater than or equal to 0, or the inside of the square root symbol is greater than or equal to 0. This is a linear function. This is a circle. So for a polynomial function, the domain is the set of all real numbers, no restrictions. For the second one, all real numbers except positive 1 because 1 will make this denominator 0. And then square root of x, it should be, this x should be greater than or equal to 0. So all real numbers greater than or equal to 0. You cannot have numbers less than 0 because that was going to be square root of a negative number, which is not a real number. So the domain has to be set of real numbers greater than or equal to 0. So that these will be functions. And then y equals 6x plus 2. The domain is the set of all real numbers, and this one, the domain is the set of real numbers from negative 3 to positive 3. So that's it for functions and relations. Thank you for watching. Comment, like, and subscribe. Bye!